Okay, so the full form of Etabs is E for extended. Okay, E for
Okay.
extended. Now, and T for three dimensional. T for three dimensional. Okay, and A for analysis, and B for building, and S for system. Okay, fine. So this is the
Yeah.
full form of ETAP, that is the extended three-dimensional analysis in building system. Okay, you add this one more term, that is the in analysis in building system. So what is the meaning of extended?
A large, like yeah, large.
It
Yes.
is not limited.
Basically, in the terms of ETAPs, here extended means we can do that whatever we want to. Okay, extended means we can use that the broad, right? Yes or no? Right? We can do that in the modeling part, that is in the broad area. Okay, so three-dimensional structure. If we extended the three-dimensional structure, one more thing, that is the three-dimensional structure. It means that in the direction X, Y, and Z we can do, right? Three-dimensional means
Yeah.
x-axis, y-axis, and z-axis. But here given that extended three-dimensional, it means that we can go on the beyond that the x, y, and z also. Okay,
Okay.
right? And here that is the term analysis. So what is the meaning of analysis? We see further. Okay, and already that is the building system. You already know that. Okay, and this software is the product of, that is the CSI company. Developer company is the developer developer company is CSI. CSI, and its full form is computer structure Inc. Okay, this is the full form, right? So the most important about that the ETABS is we have to do that the ETAB software. Okay, so we only do that the superstructure part in that. Okay,
Okay.
this software, that is important about ETABS. About ETABS. So first thing is that this is used only for building constructions. Okay, the first one, right? Okay.
Yes, sir.
Second, this is used for best concrete design, concrete design result. Okay, if we do that
Okay.
the concrete building design, so it provides that the best result. Okay. The third one about that the items, it is only used for superstructure building, superstructure component. What is the superstructure component?
Above the plinth level. Super.
Yes, so basically there are two types of structure. One is the superstructure and another one is the substructure. So substructure is basically below that the plinth level, that is the foundations. Okay, and the
Yeah.
superstructure that is above the plinth level, that is the beam and column, and slab. Okay, so
Uh,
basically beam and column, right?
yeah.
human column. Okay, now.
Mr. Sono, is it support like retaining wall?
Yes,
Can we design a retaining wall in Etabs?
yes, we can design that the shear wall. It means that we can also design that the retaining wall. There is a basic
Okay.
difference between the shear wall and retaining wall. Okay, right? Yes or no? We
Yeah.
use that the retaining wall, that is the foundations, for the foundations purpose, right?
Okay.
So if we have to do that the retaining wall, so we can only we have to use that the properties of that retaining wall, and we can design as per requirement of the shear wall. Okay, I just explained that what are the designs that is the possible in the ETABS. Okay, when we do
Okay.
work talk further. Okay, the next one, that is self weight. Okay, self weight of the structure is already included. Okay, already included. Understood? It means that we don't have to provide that the self-weighting structure. Understood?
Okay.
Now the next one, that is multiple units are available. You are doing that the Revit, right? Yes or no?
Yeah.
So have you seen that how we have to use that the multiple units?
Right. We
Okay?
have two type, imperial
Yes.
and
Yes. So according to the requirement, we can change that. No need to work on the particular unit. Okay. Suppose we are working in the imperial unit and some client required that the data we have to change in the metric unit. So we can directly change and provide that data. You don't have to go in the another project and use that the metric unit and then do that the project again, right? Yes or no?
right.
Okay.
So here also multiple units are available. Okay. Now the next one, that multiple window. Multiple window like plan view, like plan, elevation, and 3D view are also available. Okay, understood?
Okay.
Yep. So this is the another important part. Next one, that is the every Indian standard code, every IS code are available. Okay,
Okay.
for the dead load, live load, wind load, seismic load, all codes are available. Okay,
Okay.
Okay.
understood? So these are the important facts about that the ETABs. Understood?
Okay.
Now after that we talk on that code used. Code used in ETABs. What are the code we have to use? So if any code you don't have, okay, so just tell me. I send that. Okay, understood?
Yeah.
Yes.
So the first code we have to use, that is the IS 875. Okay, which one? IS 875.
It's
What is the use of that code?
Is it for concrete component?
No, this is good for the loading purpose.
Okay.
loading.
Loading. Okay. And one more thing, it has 5 parts. Okay. IS 875 have 5 parts. Okay. So what are the parts? That is the part one. Okay. Part one. Used for which one? That is the dead load.
Dead load
Okay. The
or
part
permanent
two.
load.
Yes. Part two. Dead load, basically we can't see that from the naked eye. Okay, that is the
Right.
dead load. That is the you can. What are the dead loads? Can anyone? What are the
Uh,
types of dead load?
like
Those
Mrs.
are wall loads, parabity, and
No, no, no. That is not the. That is also the dead load. But basically, if we are talking about that the dead load, okay. So that is the UDL. You can see that the
okay.
UDL. Suppose that
Yes.
if any members, So we apply that the UDL. So can we see that the UDL load are applied or not?
Yeah, yes,
It
sir.
is acting in the form of wall. Okay, right?
Yeah, yes,
So
sir.
when we applied that the wall, so the wall load are applied in the form of which? That is the
UDL.
UDL. The next one, that is the point load. Okay, what is the full form of UDL?
Uniformly distributed load.
Uniformly distributed load, right? If you don't know, you also, I suggest both of you that you also maintain your notebook. Okay,
Okay, sir.
right? So you just note it down.
But
It is very helpful to you. I also send that the notepad, but if you write that by its own hand, it is very helpful. Okay.
right.
Yes. So the full form of UDL is uniformly distributed load. What is the any other name of point load?
Point load, it is
It is also called concentrated force.
concentrated load. Yeah.
So you have to remember both of them. Okay, concentrated force. Okay, fine. Now
Okay.
the next one, that is the UVL. What is the full form of UVL?
Uh, Uniform vertical.
Uniformly varying load. Note it down.
Varying.
Uniformly varying load. It means that at we applied that load on a member, so at every point it will vary. Okay, right? So like that, these are the types of dead load. Understood?
Yes, sir.
Yes or no? Now the
Yeah.
second one, that is the part two, we have to use for the live load. Okay, for the which one? That is the live load. So any other name of live load?
Variable load.
Yes.
No,
What
sir.
is?
No.
The variable load,
It is called imposed load.
yeah, embossed
Imposed
load.
load.
Imposed load and superimposed load. Okay, the live load is also called imposed load or superimposed load.
Superimposed load.
Now the next one, that is the part third. Okay, that is used for this one, wind load.
Wind
Wind
load.
load.
Okay, the next one, part four. Part four. This is used for a snow load. A snow load
Uh,
or oblique ice load. Okay, and the
okay.
next one, that is the part five. That is used for combination load, combination load, or it is also used for a special type of load. Okay, a special type of load. Understood about that the IS 875 code.
Okay. Sir,
So
these are codes we will be used, sir, in
yes,
ETABS.
no,
Are
basically in IS 875 we use that the most important code, that is the part third window. You highlight
yeah.
this. Okay,
Okay.
so just mark this one. This is the use. This is the mostly used. We can prefer that the dead load and live load. Okay, but that is no. That is the other matters. Okay, if we have to go that on the deeply, right? We have to go
Yeah.
that in the deep. So in that case, we have to use that the dead load code and the live load. Okay.
Okay.
Otherwise, I suggest you how we have to take that the value. But the IS 875 part third is very important. When we design that the wind load structure, so this code will be very useful, right?
Okay.
And one more thing, that is the part four, a snow load. Suppose that
Okay.
we work on that the Himachal Pradesh or any that the place that have the ice fall. Okay, right?
Yeah.
Okay.
So in that case, we have to must calculate the small load also.
Yeah. Especially in Europe country.
Yes, right. So in that case, we are using that. Now the next one code. So I just suggest you that the code we have to remember that here. The first one IS 875. The second code we have to use, that is the IS 1893. 1893
Nine three.
part 1. Okay, that is for seismic load. Okay, seismic load or Earthquake load. Earthquake load. Okay, understood. Now the
Yes.
next, the third code that we have to use IS
4 5.
456 2000. That is used for
Concrete design.
concrete design.
So in ETABS, is there for steel design?
Yes, we can also use that the steel design. The next code we use that IS 800
2007.
2007. Okay, that is used for steel design. Steel design. And for the steel design, we have to also require that the steel table, right? Yes
Okay.
or no? Without a steel table,
Yeah.
we can't do that the steel design. Okay.
Yeah. Mr. Seno, IS stand for International Standard, right?
Yes, IS stands for Indian Standard.
Oh, okay, Indian Standard.
Yes, Indian Standard code we have to use. Okay.
And this Indian Standard, it's most likely like British Standard or
Yes,
American Standard.
it is almost similar to the American code, okay, and British code
Okay,
up to the 80 to 90% all the data will similar. Okay,
okay,
right?
that's
Sir, for
great.
Gulf countries, which code will be used, sir?
Basically, on the Gulf country, we use that the American code or the British code, and also we do that the Indian Standard code. Okay, because
Okay.
the data that is the 80 to 90% will be similar with all the code. Okay,
Right.
little bit variables, so we have to just think about that. If you go there, then you have to also read that the American and British code. Okay,
Okay.
so you have to must have the code in the hard copy form. Okay,
Yeah, yeah.
Okay.
soft copy as well as hard copy. Because if you have a hard copy, so you can read out very carefully. Okay, and you can underline that what are the important terms we have to use whenever required. Okay.
Yeah. I have, sir, wind load and seismic load, concrete design, steel design.
Okay.
Actually, I have none of all of them.
Okay, so I sent that all the code. I have
Yeah.
already uh, have the so many code. Okay, right. So I just show you that. You see that there are various types of code are available. Okay, so I send
Yeah.
all that the code. Okay,
Okay.
right. That is the IS 875 part one, part two, part three. Okay, IS 1893 part one. That is the old version code. That is with the editions of 2002 to 5. Okay, and now in the 2016 there is a latest 1893 code has been applied. Okay, so some data will be changing there. So I send both of the code. That is okay,
Okay.
and the SP16 and SP34 code that is also must useful. That is used for the detailing purpose. Okay, related to the detailings, every data will be given there. How we have to take.
Okay.
Okay, so you have to read out very carefully these two codes also, SP16 and SP34. Okay, so we have to next code we have to use that SP16 and SP34. Okay, that is
I
used
think
for
these are used for the columns, sir, I think.
detailing. Yes, detailing of beam, column, and slab. All these are given there.
Okay.
Okay, so you have to read this one also, because if you have a theoretical concept will be clear, so you can do that and implement your theoretical into the practical, right? Yes or no?
Yeah.
Yeah.
Yes.
So
Uh,
yes,
okay. Mr. Sono, actually, I want to ask you if you have a manual calculation for a column, a beam, using Indian standard. I want to
yes,
see the procedure.
you just follow that on the YouTube. There are various designs are given that on the
There
manual
is
calculation.
example in the code, right?
Yes, all are given that in the example how we have to do that the manual calculations. Otherwise,
Okay.
I will just show you that the manual calculations of about that the dead load. Okay, how we calculate that the building load manually,
Mm-hmm.
right? that the wind load manually also, and the seismic load already I told you that the manually, and after that we implement all that on the structure.
Okay.
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 Apart from that, if you want to see that the design of beam, okay, design of column, design of slab, design of footing, so you just go through the YouTube, okay. And otherwise, there is a one book I suggest you, that the Rama Murthy RCC book, that is for the concrete design. Okay,
What's the name again, Mr. Son?
Rama Murthy,
Rama?
Rama Murthy for the concrete.
Ramamurtam.
Can
Yes,
you write it down if you don't mind?
I just open in the Google.
Sir, in ETABS there is slab design, sir.
That is the RCC book are available. Okay, in that there are various designs are given that in the manually how we have to do that. Okay, for the RCC structure.
Sir, in ETABS we can design for the slabs, sir.
No, for the slab there is no any software are available. Okay, we is little bit doing that the safe. Otherwise we can do that the manual. Here you see that the S Samamurtam,
Yeah. Yeah.
right? Okay, so just go and download and bring that book if you want to require. Okay,
Okay, I will do that
for concrete.
for concrete.
Concrete structure. Interior. And interior. Okay, right?
Okay.
And some the best that you can go and see on the YouTube. So that is very clearly you can clear all these things. Okay,
Okay.
right? So you just prefer that the YouTube. That is the most important thing.
Right.
Right? Okay, understood? Okay, now
Yeah, Mr.
comes
Son.
to our point. So now the next one, that is the, we just start that. So these are the basic details about that items. Okay. So first we have
Okay.
seen that what is the full form of ETABS, what is the developer company, okay, what are the important points about that the ETABS, right? Okay, and the code
Yes, sir.
used, fine. And here these are the codes. I just send you that also this one. Okay. Now the next one, that is the keyword. Okay, keywords. What are the keywords used in the ETABS? Keywords of ETABS. Okay, so the first keyword is that the modeling. Okay, we can do that the modeling in the ETABS as per like that the Revit. Revit is also used for the modeling and 3D design. Yes or no?
Yeah.
So same like that we can do that the modeling in the ETABS for the structure part. Okay, right? So
Right.
here modeling can be done by the two methods. Done by the two methods, methods, and it is totally, totally based on the grid. Based on the grid. So you can also say that ETABS is the grid-based software, right? Okay.
Okay.
ETABS, you can say that because here modeling can be done by the two methods and it is totally based on the grid. So we can say in the another term, that is key Etabs is the grid-based software, right? Without grid, we can't do that the modeling in the Etabs. Understood?
Okay, sir.
Okay. So what are the two methods? The first one, that is the rectangular grid. Rectangular grid, and it is also called Cartesian grid. Okay, Cartesian grid. Understood? It means that if we have to do that the horizontal and vertical frame, okay, with the help of horizontal and vertical grid, so that is the combinations of rectangular grid. Okay.
Okay.
Now the second one, that is the cylindrical grid. Cylindrical grid, or you can tell that key, that is the circular grid. Okay. So there are two grids by which we can do that the modeling. So we can do that the grid individually if we have to work on the rectangular or cylindrical. And suppose if we have to mix that the two grid and create a different shape, okay. So in that case we can also use. Okay, we can do that the rectangular grid separately or individual. We can also use that the cylindrical grid individual, and suppose if required to mix that the two grids, that is also we can do that. Okay, understood? So
Yeah.
Okay.
clear what is the meaning of modeling. Okay,
Yeah.
and what can we do? The next one, that is the second one, that is the analysis. Okay. Yes, so Vivek, sorry, Praveen, you already know
Yes.
that what is the meaning of analysis. So
Yeah. Yes, sir.
yes, so can you explain? Because I believe that you already know that.
Yeah. Analysis is nothing but by giving the all loads, we can know the what if we have given the loads on the beams or any columns, we can know the analysis of what are like
Yes, right. So
shear
basically,
forces and displacements.
yes, yes. So basically, analysis is used for the different forms of properties or sections properties, right? Or the materials, and also for the load, right? So that is the analysis part. So we just see that what we have to do in the analysis. First, we define, okay, define material properties. Okay, what we have to do? Material properties. So what are the materials we have to use in the Etabs? That is the first one, that is the concrete material we can use. Okay,
Right.
Okay.
concrete. Another one, that is the steel material we can use. Another one, that is the rebar. What is the rebar?
Also,
Reinforcement.
reinforcement.
Reinforcement bar. Okay, reinforcement bar. We can use that the masonry material. Okay, so like that we can use that the various types of materials. Okay, understood? Second,
Right.
Okay.
we do that define define the section properties properties of beam, column and slab. Okay, right? This is another things we have to do in the analysis. The next one, that is the define various support various support of a structure, like we use that the fixed support, okay,
Right.
from a pin support. So like roller support, all this we can use in that. Okay.
Okay.
Now the last and the most important thing, that is the define the various types of load used on a structure. Okay, used on a structure. Okay, fine.
Yeah.
Okay, so we do that the analysis as an input, right? So after that, providing that the input, what we get at the output result. Okay, so we see that what is after the analysis output. So in the analysis output result, what we get, that is the first one we get, that is the support reaction. Okay, what we get, that is the support
Support.
reaction. Second we get that shear force, shear force and also shear force diagram. Okay, SFD means shear force diagram. And the next one,
Bending
that is the
moment.
bending moment
Diagram.
and bending moment diagram. Bending moment, that is the shear force means the calculations of forces, right? What
Yeah.
is the shear force and what is the bending moment?
Like
Yes.
the shear force, at which load the component or the structure will like break or like
No, no.
will
Shear force is basically the sum of all vertical forces acting on a particular span. Okay,
right.
Yeah.
that is called that the shear force. The sum
And
of all vertical forces acting on a particular member or span, that is called shear force. And bending moment, the sum of all moments acting on a particular span. Okay, that is called bending moment. Okay.
Yes.
Yes. The next one that we get, that is the axial force. Axial force. Another one we get, that is the deflection. Okay. So these are the result we can get. Okay. Understood?
Yeah.
Now the third term we use, that is the design. What is the third term we use? That is the design. So what are the designs we have to do in the Etabs? So first one, that is the concrete frame design. Concrete frame design. Second, we do that steel frame design, steel frame design, and steel connection. Okay, steel connection. Next, we do that is the truss design. Okay. Next, we do that is the shear wall design, shear wall oblique retaining wall design. Okay.
Sir, in concrete frame design, it will become the reinforcement. Okay?
Yes.
In concrete design, it will become on in the part of the reinforcement. Okay?
Yes. Reinforcement. Area of reinforcement. Okay. Okay. Next one, that is the composite beam design. What is the meaning of composite? Huh?
as you said, life
Combination of
load.
What? Composite
all
what?
combination of beams and columns designing
No.
like amount of reinforcement.
Basically, composite, it means that we can mix that the concrete and steel together. That is the composite structure. Okay. Suppose in the concrete we mix that the steel structure. That is the I section, angle section, channel section, pipe sections. Yes or no? So these are the
Yeah.
steel sections. So if we mix these two sections, that is the mix of two material. That is the composite structure. Okay,
Okay.
and that provides you that the better strength as comparison to the concrete or steel. Okay, because we have mixed these
Okay.
two members. Okay, but it, when we cast this one, so it may be costly, maybe not,
Okay.
it must be costly, okay, as comparison to the concrete design or steel design. Okay,
Yeah.
fine. So these are the design we have to prefer in the ETABS, and after that the design, what we get, that is
The
the
result.
design output result. Output result.
Mr. Sono, like in design, can we design for a timber?
No, we can't. We only design that the concrete, steel, masonry, these type of structures, not timber.
Okay.
Okay, because timber and aluminum we can't design in the STATCO also and in the ETABS also. In the STATCO also given that the term that is the timber and aluminum, but we can't do that the design of that.
Okay.
Basically, we use for the concrete and steel design. Okay.
Okay.
Now in the design result, first is provide that area of reinforcement steel. Reinforcement steel, that is denoted as AST. Okay,
Yeah.
right?
Yeah.
Second, it provides that percentage of steel in beam and column. Okay, what are the percentage of steel we have to use? Now the third, it specify that area of shear reinforcement. Shear reinforcement steel. Okay, so these are the results. These are the results we get after that the design. Okay. Now the final and last term, that is the detail. Okay.
So meaning of steel reinforcement means what?
What? Shear
Steel
reinforcement.
reinforcement.
Meaning of steel reinforcement? Reinforcement is steel.
Difference between reinforcement steel and shear reinforcement steel.
Okay.
Yeah, there is a difference between
Difference
shear
between the
reinforcement.
difference between, you want to know that the difference between reinforcement is steel and shear reinforcement is steel,
Yeah,
right?
yes, sir.
Okay. So basically, reinforcement is steel. We have to provide that particular the number of bars. Okay. The main reinforcement, that is the longitudinal reinforcement. Okay,
Okay.
so that is the reinforcement steel, that is the, you can also call main steel. Okay,
Okay. Shear reinforcement stirrups, sir.
yes,
Giving
basically
the
the
stirrup.
shear reinforcement we can use that the stirrups also, and the total maximum load we can apply it on that also. Okay,
Okay. Okay.
and reinforcement steel you can also told that the main steel. Okay, the longitudinal steel you can also. Now the next one, that is the detailing. So what we do that in the detailing, so after the detailing, okay, right, after the detailing, first we get that the drawing sheets. Okay, drawing sheet of beam and column, right, beam and column, we get that the drawing sheet of beam and column, right, and also wall. Okay, if we are doing that the shear wall, so it provides that also the reinforcement. So right now we only do that beam and column. The second one, it's so that the reinforcement cage, reinforcement cage view. Okay, what is the meaning of reinforcement cage view? It means that you have seen that on the site when the constructions started, right?
Yeah.
So first, what we do, we first import that the reinforcement, right? How we have
Yes,
to
sir.
arrange that. So that view also visualize in the ETABS for the beam, column, and shear wall. Okay,
Okay.
how we have to arrange that the bars, what are the number of bars we have to
Okay.
use, how
Giving
many
the
stairs.
spaces and
Yes, all these
component.
things we have to see that in the 3D view. Okay,
Okay.
but we can't say that that is only the for the visualizations of engineers. Okay, so you can just check that how we have to construct that the beam and column at your site. Okay,
Okay. Okay.
Now, in the next part, it generates the report. Generates the report in two format. In two format. That is the first one. That is the project report, project and summary report. Okay, understood or not?
Yes.
Yeah.
Okay. And we can also export that the summary report or project report into the Word file. Okay, and this report is very useful when we do that the thesis of MTech or PhD on the Etabs. Okay, so in that case, that reports is very useful, right?
Okay.
Mr. Sono, in this report we can do some modification.
If we export in the Word format, so we can do that the modifications as you want.
For in case, Mr. Sono, we have a failure in our design, so we
Yes,
want to recheck back our design. So sometimes in Malaysia we use Brota structure software.
yes,
So our lecture said that we can do some modification on the report, then we can make the design pass.
yes. The structure. If you do that in the as a structural engineer, okay, right.
Yeah,
So without modifications, we can't send that the report.
right.
Okay, because if you directly send that the report as per the working on the software, right? Like
Yeah,
the Statco and Etabs, which whatever software you are using, in that case you can directly send that it will be maybe it's some mistakes. Okay,
yeah,
so you have to just modify that. Suppose that in sometimes we have to manipulate in the reinforcement details also. Okay, suppose software suggests that the 12 bars, okay, of three numbers, right? But we
right.
have to
Okay.
suppose that if we use that the two numbers of 12 bars, so it is sufficient. So why we provide that the three bars are there, right? Yes or no? So we
Yeah,
do that the manipulations of result in also.
right.
Okay, so these are
Okay.
the basic introductions about that the detailing part. Understood?
Yeah,
Yeah.
So you just do today. If any confusions, any query in that, okay, we discuss
yeah.
tomorrow. And tomorrow we start that the working of Etabs. This is the
Okay.
working screen of Etabs. That is here also you see that integrated building design software. It is given that you can
Yeah.
check that the latest news, resources, all these things online.
Okay.
Okay.
Mr.
Sir,
Sono, actually,
This
yeah.
is
Go
called
ahead,
that
brother.
this is the called that the menu bar. Okay. This is
Right.
called menu bar,
Minibar.
mm,
and this one, and on the top this one, and on the left
Revit.
side of the screen that is called all our toolbar. Okay.
okay.
Yes. Ask any
Sir,
query.
generally for you for any analysis of the building, which software you will choose, sir, to
What?
giving the details for any buildings to the clients, which software you will use
Basically,
for the
right now in the market, okay, right now in the market, we use that the ETAP software. Most of the